Welcome to this video. Here we are going to see about the experiment of determination of coefficient of friction and angle of repose of a given sample. First we are going to identify the angle of repose. For angle of repose we require, there are two types of equipment of resins. First one is round type and then that is L type. For the materials required for this experiments are this two equipments and weighing machine sample. These are the requirement for this experiment. Now the procedure of this experiment is, first for the round type we have to measure the diameter of this circle where we are going to poke the given sample. From feeding the given sample, it will form like a hip-like structure. From the hip-like structure, we have to measure the height of the hip, and then we have to measure the diameter of the circle, which is considered as a base for the cone shape formation. For measuring the height of the hip, we can use this screw here. There is a scale which is placed inbuilt in this equipment. From this scale, we can measure the length, height of this hip formed by the given sample. Then L type. Here it is a simple method. Just we have to pour the feed in the sample in this box, and we have to slightly pull out this slider slowly, which will form a L shape. A slide-like component will be formed by the given. For angle of repose from round type, this is a schematic diagram of the formation of feed given through the funnel. From this inner circle, we have to measure the height of the grains. Then the calculation part. First, as I said before, we have to measure the diameter of the circular plate, then radius of the circular plate from the diameter, and height of the hip. From this we can use the formula, which is angle of repose is equal to tan inverse of height divided by radius. From this we can identify the angle of repose for the given sample for the round type. For L type, we have to measure the length. As we said, it forms a slide like structure. We have to measure the length of the grains drain out from the container, and the height of the grain drain out from the container. From this we can calculate the angle of repose, which is equal to tan inverse into height divided by length. From this we can calculate the angle of repose from the L type methods. For angle of coefficient, we are going to use this apparatus. It consists of a container where we can pour grains at a particular weight, and then it consists of a pulley. Here we have to add a certain amount of weight, from which it gets start to move from one area to another area. Here we are going to use 4 different kinds of material. One is acrylic, second one is iron, third one is copper, and final one is stainless steel. Okay. For this surface, 4 different surfaces, we are going to find the coefficient of friction. For first, we have to place the plates in a proper manner. Then we have to place this container here, like I am showing now. Then first weigh the sample and then fill the sample here. After adding weight on here, it going to start get dragged by the force which is added by here. First you have to mark where it starts dragged by the force. So we have to mark the starting point here, where if it is coming up to this end means we have to mark this point. This is your length traveled by the grain due to pull, or you can say it is a force. Okay. Then we have to calculate the weight added here. From this we can proceed for calculation. As I said, for calculation we have to calculate, we have to note down the surface, type of the surface, weight of the grain which is added in the container, and the weight added at the end of the pulley. From this parameter we can find coefficient of friction using this formula, which is coefficient of friction is equal to F by W. F means weight added to the pulley, and W means the weight of the grain which is we are added in the container. From this we can identify the coefficient of friction for different surfaces. This is the result. For the result we are going to write angle of repose of the given sample and coefficient of friction of a given sample on 4 different surfaces. Thank you.